This first part on the top is going to come up a little bit later when we do something called completing the square. You don't really need to know that for now, but I'm going to try to say this. If we were to have this square, and I'm going to say this length here is A, and this length here is B. So do you agree the length of that whole side is going to be A plus B? Cool. And then if those are all, well, if A is a square, then I'm going to be able to say that this top part here is A, and right below it I have B. So that side also would have a length of A plus B. Well, if we wanted to figure out the area of that whole thing, do you agree we could say, since it's a square, we could say it's A plus B squared? Yeah. And then in the notes yesterday, I made the comment that said, a lot of people say the answer to that is A squared plus B squared. Is that right or wrong? Wrong. Because you only can take the 2 and apply it to everything inside if it's multiplication between those, not if it's addition. So we have to instead say A plus B quantity squared is the same as A plus B times A plus B. Good? And then in yesterday's notes, we were saying, all right, if we want to figure that out, well, we do this times this, and that's going to give me an A squared. Then we do this times this, and it gives me a positive 1AB. So I'm just going to write plus AB. Still tracking with me? Then we do the same thing. We distribute that B. So we do B times A, which gives me positive 1AB. So we write it alphabetically. Even though we did B times A, it's A times B. And then we have positive B times positive B for a positive B squared. And in ones like these, they're kind of a special case where these two can always be combined. So I have this A squared out in front. Then I have how many ABs? 2. So plus 2AB. And then I have this plus B squared right there. Good? Yep. So what we really just found was I have A squared. What's A squared over here on this thing? Square. It's the big square, right? That the area of this big square is going to be A times A, or A squared. The rectangle to the right is going to have an area of A times B, right? Because this length here is A, and you do length times width to find the area. Yeah? Yep. Yeah. So that's going to be this one, that second one. The area of this rectangle down here is going to be A times B. So that's my other AB there. And then last but not least, we have something that's a side B times a side B, so a B squared. So you see how it kind of works as you could look at it geometrically in addition to algebraically. You could look at it like a shape. Where we're going with this a little bit later is that we'll give you something where you're missing this part here. So that part's gone, and then we have to add that in. That's the next chapter. That I get really excited about. I think that's really cool, honestly. I'm really excited about that. I just like math. Math is awesome. Okay, perfect square trinomials. Here's the new stuff. So perfect square trinomials come from squaring a binomial. So a binomial was something that had 2 terms or 2 parts, like this up here. This is a binomial. And if we square a binomial, if we do the binomial times itself, we get what we have right here, which is called a perfect square trinomial. Trinomial because there's 3 parts, and a perfect square because it fits something that's a square shape, a perfect square. But we'll do a little bit more of that later. Now, here are a couple, I don't know if I can officially call them formulas, but here are a couple things that will help you later on in understanding stuff. Some people use it now, but if you were to have A plus B squared, like we did, that's going to equal A squared plus 2AB plus B squared. And essentially I just copied down what we did right up above. Fair enough? If we could take that problem, and I'm going to change this to a blue plus right there. If we write the exact same thing, but we put a minus in there. So if I do instead of A minus B quantity squared, That's going to give me the exact same answer, but one thing is going to be different. That's going to give me an a squared minus, nice. Have you guys seen it before? Okay,
Yeah.
plus b squared or minus b squared?
Minus.
Well, if we go back up here, plus, because if we have a negative b times a negative b, negative times negative gives us a
Positive.
positive. So we still have the plus b squared. So the theory for now is, oh, some of you might find this really handy. You know, if I give you an x plus 2 quantity squared, and I don't know if this is worth writing out. I guess I could call it, I should just do an example. So let's do the examples down below. I'll get rid of that. What if we go down below? What you could do, and most people don't do it this way, honestly. I see the value in this thing in this red rectangle. I see the value coming up in the next chapter. I don't see a whole lot of value in it right now because most people don't use it. But they're saying this. This fits that top one, yes? That it's something plus something quantity squared. So we could take this answer, well, a is going to be x, agreed? So instead of a squared, I would write x squared. And then I have, next I'm going to have a plus 2ab. Well, I have 2 times a is what? X, and b is 4. So I have 2 times x times 4, which is the same as plus 8x, because you could do the 2 times 4 times x. And then I end up with over here a plus b squared. B is 4, so it's going to be plus 16. You are welcome to do it that way. Quite honestly, I find it a whole lot easier to say that's x plus 4 times x plus 4. And then I just go through and do the type of thing that we did up here. I didn't quite give myself enough space, but if I go through and do it, I get x times x, which is x squared. Then I do x times 4, which is plus 4x. Then I do inside, so plus 4x. Then I do last, plus 16. And then I combine these two to give me 8. So 8x. So, can I do it my way for this one over here?
Yes.
If you want to go through and use this right here, the a minus b quantity squared, go for it. I'm going to instead just do this. This is how I do. I go back to foiling like we learned in the last chapter. So x minus 6 times x minus 6. Because it's a binomial times a binomial, we could do the first, outside, inside, last. So when we do the first, that's going to be x times x, or x squared. Then we could do the outside, which is x times a minus 6, so negative 6x. Then we could do inside, which is another minus 6x. And then we could do last. That won't show up very well. Last, which is negative 6 times negative 6, or
36.
Plus or minus? Plus 36. And then you can take, of course you're smart, you can take and combine these two together and say that's minus 12x. So we have a x squared minus 12x plus 36. That's how I choose to do it, preferably without crossing the problem out at the end, but that's how I do it. Do example 3?
Nope.
Shouldn't have phrased it quite like that. So example 3, same type of thing, I just made the numbers a little bit prettier. I mean, made it a cooler problem. So we have that right there. Because it's a binomial times a binomial, we still can do the foiling, which is really just the same as doing distributive like we were doing before. But I do 3x times 3x, which gives me 9x squared. Because 3 times 3 is 9, x times x is the x squared. 3x times a positive 8y gives me positive
84.
should be 24. Because 3 times 8 is 24. X, and then an xy. Good. The inside, if it's a binomial times itself, do you agree so far outside and inside have always been identical when we do ones like that? So this also will be a plus 24xy. That's only if the two binomials are identical. Otherwise, do it old school. 8 times 3 is 24. They're both positive. And I have an x times y. We always write the variables alphabetically. Agreed?
Yeah.
Then, last but not least, we do the last together. 64y squared. Good. And then these two have the exact same variable combinations. We can combine those. I'm going to start at the beginning. 9x squared plus 48xy plus 64y squared. Looks like we got a couple other ones. Get rid of those. I'm feeling like you guys are getting it. Should I jump to example 5?
No.
Yes.
Example 5. Okay, so if we do example 5, and I can always hit example 4 at the end. But if we do this one, we distribute. Now, these aren't identical. Well, maybe I should do both. Let's do both. X times x is x.
Squared.
If we do the outside, we get a minus 2x. Inside is plus 2x. Last is minus 4, because positive 2 times negative 2 gives me a negative 4. And now when we combine the outside and the inside, those two middle ones, we get a nothing. They just cancel, right? So final answer is x squared minus 4. And this will be something that pops up in the next chapter too. But if you notice, we started out with the exact same binomials, but the signs were opposite each other. Outside and inside just cancel. So if you recognize that in this next one, really when we FOIL, the only ones you have to do are first and last, because outside and inside are going to cancel. But if we don't catch that, then you just do the whole thing. So 3x to the 4th times 3x to the 4th is 9x to the 8th. Then we do outside, we get a 3, positive negative. Negative 3, x to the 4th, y squared. And now when we do the inside, same thing but positive. So we get a positive 3 x to the 4th y squared. And then last but not least, positive y squared times a negative y squared gives me minus y to the 4th. And just like some of us predicted, the outside and inside, those just cancel. So we're left with 9x to the 8th minus y to the 4th. I wouldn't get in the habit of just not doing outside and inside unless you recognize that those two are going to cancel, because identical binomials with different signs. That's it.